Добрый день, друзья. Давайте еще буквально секундочку подождем, сейчас все подключатся. И давайте начинать. Рада приветствовать вас на вебинаре компании Proto совместно с компанией DBmarlin. Наш вебинар посвящен задачам мониторинга производительности баз данных и также продукту для углубленного мониторинга производительности системы управления баз данных DBmarlin. Меня зовут Денис Бескаравайный, я в компании Proto возглавляю DevOps и DevSecOps направления. Сегодня основным спикером будет Мик МакГиннес, co-founder компании DBmarlin. Hi, Mick.
Hi, Dennis.
И также среди спикеров у нас сегодня Рассел Люк, также co-founder компании DBmarlin. Hi, Russell.
Hi, Dennis. Hello, everybody.
Сегодня план нашего вебинара следующий. Мы осветим ключевые заявленные темы и вживую посмотрим на демонстрацию. Среди наших основных тем: какие задачи должен решать современный продукт для мониторинга баз данных, кто выигрывает от улучшения мониторинга с УБД, и это не только DBA, мы сегодня про это узнаем, что отличает продукт DBmarlin от конкурентов. После этого мы прервемся на короткую сессию вопросов-ответов, посмотрим живую демонстрацию, и после этого будет еще одна сессия вопросов-ответов. Свои вопросы и ответы, пожалуйста, пишите в чат. У нас есть и чат, и секция вопросов и ответов, как удобнее. Для тех, кто с нами еще не знаком, несколько слов о нашей компании, о том, как мы узнали о DBmarlin. Мы уже несколько лет занимаемся DevOps и DevSecOps проектами, активно внедряем решения по мониторингу производительности приложений, занимаемся всем, что связано с мониторингом Kubernetes и других Cloud-Native технологий. Имеем опыт использования open-source решений, вендорских решений, таких как New Relic, AppDynamics. И последние полтора года активно работаем с вендором Instana, и как раз благодаря Instana мы узнали о решении DBmarlin. Собственно, это продукт, который позволяет ответить на ключевые вопросы, которые касаются производительности баз данных. Опыт коллег нам показался очень интересным, и, собственно, сегодня я очень рад представить Мика, который и расскажет про основные задачи и как они решаются с помощью продукта DBmarlin. На этом я передаю слово Мику. So, Mick, you are good to go. И еще одно маленькое объявление, что у нас большая часть будет на английском, но вопросы можете писать на русском, мы их транслируем на английском. Спасибо.
Okay, thank you, Dennis. Let me share my screen. Hopefully everybody can see that. So, yeah, thank you for hosting the webinar, and thank you everybody for joining. My name is Mick McGuinness. I'm the DBmarlin product manager, and I'm also the co-founder of Application Performance Limited. We're a UK company, and we provide software and services to help customers to improve the performance of their applications and databases. And we've been doing that since 2004. So DBmarlin is the product, Application Performance is the company. My background in IT, I've been working in IT for 25 years, and the majority of that time I've been working as an application and database performance specialist, so helping customers to advise them around monitoring strategies and helping them to optimize and tune their applications and databases. I actually started as a developer DBA. My first job was working on Oracle 7 back in 1996. So the story behind DBmarlin, the team here that came together, first of all, 23 years ago. We started with a product called Precise SQL. It was one of the first tools to monitor Oracle. It eventually evolved to become one of the first APM, end-to-end application performance monitoring solutions. And that product's still there. It's over 20 years old, but it's still there. It's still used around the world. More recently than that, we created a product called DB Tuner. That eventually sold to AppDynamics. That was a very successful product. And again, that product is still used today by thousands of customers around the world. It's now the AppDynamics database monitoring part within Cisco. But we'd felt for some time that there was the need for a new approach, a new modern approach to database monitoring. And it's almost a year to the date since the idea for DBmarlin was born. We started in March of last year, and the first product launched in December of last year, and we're continuing to do monthly releases to build more and more functionality. The goal for DBmarlin was to make it easy for both non-DBAs and DBAs to optimize databases. So these days we don't see database optimization just as something only for DBAs. We see lots of other roles that should have access and visibility into database performance, and I'll touch on that as we go through the presentation. So the first question we're going to talk about is, what tasks should a modern database monitoring product solve? So before I get into that, just taking one step back, why monitor databases at all? Well, from our experience, databases tend to be the #1 cause of application performance problems that lead to poor end user experience. I've been doing consulting for 23 years in this space, and many hundreds of performance reviews for customers. And what we find is that in probably more than half of cases when we do a performance review for a customer, the database is one of the main bottlenecks where we identify problems that can be resolved. Obviously, there's other things in front of the database. There's the client side and the network side, but quite often those are outside of your control anyway. If it's an application where the end user could be anywhere in the world and could be coming over the internet. So generally the things you have the most control over are on the server side. And when you get into that, databases tend to be a big cause of performance problems. And that can be down to things like inefficient code or SQL. Maybe you're making too many calls to the database. Maybe you're fetching too much data from the database, or maybe you're having to scan more records than you actually needed because you don't have the right indexing strategy. Or it could be the database performance itself. You need to tune the database. Or it could be resource contention. You could be hitting limits on things like CPU or disk I/O. So those are all things that can cause issues. So given that the database is, as we see it, the #1 cause of application performance problems, what are the top causes of database performance issues? Well, I've categorized some of them here on the left-hand side. So a big one is data volumes. Data is growing at a phenomenal rate. And what we see is that quite often you get the case where something performs well in development and maybe test, and then when it gets into production, where the data volumes are orders of magnitude higher, then you start to get performance problems and scalability issues. Another big one we see here is change. You'll probably know that anytime you change anything, whether it's a schema change, a code change, a configuration change, like a database parameter, for example, or an infrastructure change, like moving from, say, on-prem to the cloud, anything you change has got a potential to impact the performance either positively or negatively. Then you've got technology issues. This could be things like code or SQL again. It could be hardware failures. It could be software bugs. It could be resource contention. And then last but not least, you've got the people factor. You can never rule out completely human error. People will make mistakes. That could be end users. Maybe somebody's run the ad hoc query in the middle of the day and forgot to add the where clause, and they're trawling through tens of millions of records and killing performance for everybody. Or it could be, for example, on the deployment side, maybe an index that was in development didn't carry through into test and into production, and that was a vital index that was needed for performance. So all of these are the common things we see with databases. And to answer the first question, what does a database monitoring tool need? Well, it really needs to be able to help you with all of these, either to avoid them completely, or if you do get them, it needs to be able to resolve them as quickly as possible. So when we started to build out DBmarlin, we surveyed a number of our customers and to look at the existing tooling they have for databases. And generally they fall into one of these categories here. These are some of the weaknesses we saw in what was out there. So people either have a complete lack of monitoring tools, so they're flying blind, they're firefighting problems when they arise, but they're working in a very reactive mode. So I think about 1/3 of customers have no database monitoring at all. They just rely on expert DBAs with SQL scripts to be able to troubleshoot when problems arise. Then at the other end of the spectrum, you have the people that have way too many monitoring tools and they're looking to consolidate. The problem if you have too many monitoring tools is then you have this steep learning curve and you're having to switch between different tools that give you different views of data, different metrics. So to give you one example, a customer we spoke to a few weeks ago had 6 different database platforms and 6 different monitoring tools, one for each. So the Amazon RDS was monitored by CloudWatch, the Oracle was monitored by Enterprise Manager, the Postgres and the MySQL was monitored by open source tools. And there was no consistent view across those, so it made troubleshooting across them very difficult. Then there's the customers that have some tools, but they're either poor or maybe too complex, so they require experts. So what we see, a lot of tools that just provide a bunch of metrics. You know, they'll give you charts with lines on the charts that go up and down, but there's no indication whether that is good or bad unless you have an expert to be able to interpret them. So those tools tend to sit in silos with maybe like one team like a DBA, but they're not tools that are shared across the organization between different teams. Moving down to the bottom here, the understanding change and the impact that change had on performance, that is something that most tooling doesn't have. Most monitoring has no awareness of changes to the environment. And as we touched on one of the previous slides, change is one of the #1 causes of database performance issues. So we believe that you need to be able to bring together change and performance into a single view. A lot of tools out there don't have support for modern technologies. Some of the ones I mentioned earlier have been around for 10, if not 20 years. So they look quite dated, both in appearance and support for their modern technologies. And a lot of tools we saw for database have very poor granularity. Some of them are just collecting data once a day or once an hour. And obviously you can then miss a lot of problems. So we believe that if you could address all of these, you can have a tool that solved all of those common database problems I mentioned on the last slide. And you've got a single tool that goes across platforms, is not too complex, so it can be used by lots of different people, has good granularity, support for modern platforms, and can understand change. Then that's what we think the ideal modern database monitoring tool should look like. So having a tool like that, then who benefits from that? And the clue here in brackets, it's not just DBAs these days. So lots of different roles will want some visibility into database performance. Here are just some of the common ones that we see. So starting from the top, we've got DevOps engineers. They're the people that are responsible for deploying new code into production. And generally that's on a regular basis these days. It may be multiple changes per day or per week. And one of their biggest challenges is to be able to validate a release. They need to know when that new deployment went in, did it have any positive or negative impact on performance? And if it was a negative impact, they either need to roll that back quickly or they need to be able to troubleshoot and fix it. So that's sorry, I've skipped one, two, any slides, there we go. So moving on to performance testing, that's a different use case again. So people running load tests, what they want to be able to see generally is they want to be able to compare load test A and load test B and see were there any degradations in performance. And if performance has got worse, then they need to be able to do that analysis to see why it's got worse. What was the difference between load test A and B? Which SQL statements are now getting called more often? Which ones are now taking longer? Which database weights have increased, and so on. Then you've got SRE, site reliability engineers or performance engineers. They want to see a holistic view of performance across everything, and database is a big part of that, as we said earlier. So they would want to know which of their busiest databases and which of their busiest SQL statements within those databases, so they can look to make the site more performance, more scalable, and more reliable. Then down here, we've got developers. Developers, they're interested in knowing how their code performs. So the SQL statements they've written, they want to know what impact their statements had on the database. And if any of their statements are taking too long, they need to be able to get to the root cause of why. So they're looking at how long their statements took, what database resources they were consuming, what the cost of those statements were. And then generally they would want to get down into something like an explain plan to be able to see the tables and indexes that were being accessed. Then there's the managers, various different types of manager. Could be database managers who just want a top level view across all their databases. Then there's other types of managers that could be change managers or incident managers that need detail around those kinds of things, or application owners. And then last but not least, we've got database administrators. I've put them last deliberately, but obviously DBAs are still probably the number one role who needs to be able to troubleshoot database performance, but they're not the only ones these days. They want to be able to tune the database parameters, make sure that there's enough hardware capacity to be able to support the workloads that the application is hitting the database with. And if you can get all of these people using the same tool, so they've got a single source of the truth, they can then collaborate with each other. So they can share links, performance test finds something, they fire it to a developer, can you have a look at this statement? Or fire it off to a DBA, can you have a look at the database weights seem to have increased, that kind of thing. So that's the benefit of having a tool that can be used for collaboration like that. So moving on to DBmarlin then, and why we think DBmarlin stands out from the competition. So this one slide kind of summarizes our key features and what we have in the product. So we have a single installation of DBmarlin. It can run on either Windows or Linux. And from that one installation, you can monitor a variety of different databases. These are the ones we're currently supporting: Oracle, Postgres, SQL Server, MySQL, and anything else that derives from the open source databases. So like MySQL, so MariaDB would be supported, Percona, ExtraDB would be supported, Timescale DB, which derives from Postgres, would be supported. So we're already supporting maybe more than 60% of all the databases out there just with these top relational databases here. Where we go next, we're going to follow the market and see which are the next most popular databases. We've certainly had lots of requests in the conversations we've had so far for others. Already we can support these databases here if you're running them in the cloud, so Azure or AWS. We can support them there as well. So Amazon RDS or Azure SQL, we can monitor those databases. And we also have host level monitoring for Windows and Linux as well. So running you through some of the key features then, DBmarlin is very low overhead. It means it's safe to run in production. It's got a very rapid installation. You can be up and running with this in under 5 minutes. We have real-time data, so you're not waiting for new data to come through. There's no lag. You can see up to the second what's happening on any of your databases right now. But we also have historical data as well. So you can look back in time, you can troubleshoot after the event, you can look at what was happening yesterday or last week. We have 1 second level granularity, which means you can troubleshoot, even if issues are only lasting for a short period of time, you can still drill into those and see exactly what happened during that short time window. We have a nice modern responsive web app for our user interface. It can be viewed on any device, whether you're on your laptop or your tablet or even your mobile phone, you can access the data. And we're providing this single pane of glass across all of the different databases we're looking at. So when I jump into the demo in a few minutes, you'll see that whether you're looking at an Oracle or a SQL Server or a Postgres, you're getting exactly the same view of the data. And the data that we're collecting, so the main things are the SQL statements, obviously. We need to know which are our heaviest statements, how long they're taking, and then importantly, the wait events to know where the delays are on those statements. But overlaid on top of that, we have change detection, automatic change detection, which means that DBmarlin can auto detect things like changes to parameters, changes to schema objects, even changes to explain plans. So if the cost of a statement increases, we can detect that as well. And then what we've just added in this new version I'm going to show you there is our time comparison feature. So anytime you make a change, you can see the impact. So for example, you do a new code release and you want to analyze 10 minutes before and 10 minutes after that change and see what the differences were. You can now do that. And then lastly, we have an API. So our API lets us integrate with other tools within your ecosystem. So that could be continuous integration tools, it could be load testing tools, it could be other APM tools such as Instana. So I think that's my last slide. Yeah, we'll take any questions at this point. Before I jump into the demo, we can do more questions at the end after the demo as well. But if there's any questions come up so far, I don't have the panel open. Dennis, are you able to see any questions so far?
I don't think we have any questions so far. Если есть вопросы, пожалуйста, пишите в чатик или в специальное окошко для вопросов. Mick, can you tell us more about the managed in the cloud databases? So how do you, is there any limitations? So for example, are there any list of supported cloud providers, or it's open list, I would say?
Yeah, so right now, the ones we've tested against and the ones we have customers running on are the Amazon RDS and Azure SQL. Beyond that, I think it should work with any cloud vendor. The reason being that we're not an agent-based technology. We don't have to install anything onto the database itself. We just need to be able to make a remote connection to it.
Mm-hmm.
So in theory, it should work with Google Cloud, it should work with IBM Cloud, it should work with any kind of cloud.
Yeah, we tested it with Russian cloud provider, Yandex Cloud managed database for Postgres, and it works. Excellent. So technically, there is no reason to not work for Russian cloud providers.
That's excellent. Yeah, good to know. We can add that to our list of supported platforms. Any other questions, Dennis?
We have a question regarding the pricing. Как лицензируется, какова стоимость? So can you tell us about the licensing policy and the pricing? So how is the pricing looks like?
Yes, so we're pricing by the number of sensors that you have. The sensor generally points to a database instance. So it would be based on the number of those. We don't take into account things like what technology it was. So it doesn't matter if it was Oracle or SQL or MySQL. We don't take into account the hardware sizing, like the number of CPUs or memory. So we try to keep it simple. So you just count up the number of database instances you want to monitor. And it's the instances, not the databases. So you could have an instance with 50 databases inside that instance, but it's the instance that you need to count. So yeah, there's a price per instance, and it's done on a subscription model. And we do have some current discounts for early customers right now. So that's on the website.
Great, thank you. I'll switch to Russian for a few seconds. Еще у нас вариант, есть ли вариант стендалон установки в закрытом контуре организации? Здесь надо сказать, что в принципе продукт как бы подразумевает установку у себя, да, то есть это не управляемый сервис, это не SaaS, это в чистом виде, то есть вы просто берете продукт и у себя устанавливаете. Mick, can you tell us more about the architecture? So where the server needs to be running, is it anything else that you need to run or install except the server in your environment? Do you need to install the agents on the databases or something like this?
So the architecture is, It's all self-contained, so you download the package for Windows or Linux and install that, and everything is self-contained then. You would want to install it onto a server close to your database, wherever your database servers are running, but you don't actually install anything onto the database server itself. So you just need to be able to make a remote connection.
Okay, great. Let me emphasize this. Архитектура продукта такова, что есть некий сервер, он один, желательно его размещать поближе к самой базе данных. То есть если у вас несколько дата-центров, вы можете использовать несколько серверов DBmarlin, а, соответственно, на базу данных не требуется устанавливать какого-либо агента. Все базы, ну, все метрики, все данные с баз данных собираются как бы удаленно со стороны сервера. То есть сервер ходит в базу данных и вычитывает все, что нужно, без установки агента на базу данных. Okay, I think we don't have any more questions right now, so I think we should move on to the demo.
Okay, excellent. So to get started with DBmarlin, you can go to the website. You can just enter your email address and click the Get Started button here. That will take you to the downloads. We need either a 64-bit Windows or 64-bit Linux server or VM to install this on. And then you would get the download package. We do have a new release coming out next week. So the one that I'm going to show on the demo is a kind of pre-released version of 1.3, which isn't on the download site yet. So if you're going to download, and if you see that it looks different to what I show you, that's you maybe need to do the upgrade next week. What we're doing at the moment is releasing monthly. So we've got lots of new features that we're adding on a monthly basis. So this version here that I'm going to show you, this is our 1.3 release, which will come out next week. And I wanted to show this because it has some new functionality that we're quite excited about. So once you've installed that software, like I said, it should be less than 5 minutes, install it onto a Windows or Linux VM. First thing you need to do is you need to go into your settings and add some database instances and hosts as well if you want to monitor hosts. And all we need to do is to give it some remote connectivity details. So if I click Create, select my instance type, like MySQL, I can then just give it some kind of name, IP address, and port number, 306, and there's some username and password. Documentation describes what permissions this actually requires. And then if you're monitoring the host as well, you can map between the host and the database so that you've got that relationship between host metrics and database metrics. So having done that, then you can start the sensors up, and if they're running, you should see a green icon and a tooltip that says sensor started. Some of my databases here that are down, and you can see, the databases are down here in this case. Once you're monitoring them, then you head over to the analysis part, and so I'll click into database instances here. This first screen is your kind of high-level overview across all database instances that you're monitoring. So we can see, in fact, maybe because I'm on a smaller screen, I'll just minimize this up. We can see all the databases we're monitoring here, and in my case, I've got about 20. I can sort by their average response time. I can sort by number of executions, or I can sort by total database time. So in this case, you see we've got lots of different database types, some Oracles, some Postgres, SQL servers, and so on. And our top database is a Postgres 11 instance. It's taken 16 hours worth of database time, and that was 57,000 SQL statements executed, averaging 1 second each. So that's our busiest database. We can also see during the time range we're looking at here, there were 6 changes to that database as well. So from here, we can then drill down further into the database to see what was going on the database here. Now, in this case, the database time, which is this kind of green color here, you see it was very high it then dropped down to quite a low level for a while, and then it shot back up to a very high number again here. Now this is where I was talking about the change detection. We have automatic change detection, and we overlay that onto the timeline. What you can see with the dotted lines here is that there were some changes that happened at this point in time that seem to correlate with that drop in that improvement in performance. And then there were 3 more changes that happened here that correlate with when the performance went bad again. So what we can do, again, I'm just going to do it this way so I can show it on my screen. If we go down to our changes tab here, we can list out what those 6 changes were. So the first 3 changes came with a code release, and 2 indexes were created here, and that's where the performance got better. And then at 30 minutes past the hour, there was another code release, and those same 2 indexes then got dropped, and that's when the performance then went bad again. So very clear correlation here between the change and the performance. So we already know, we're pretty close to understanding what the root cause is here. It's the fact that this code release happened and these 2 indexes ended up getting dropped. So the code, the index changes like the creations and drops, these are automatically picked up by DBmarlin. You don't need to do anything for that. We're auto detecting those. The code releases, we obviously don't know about code releases. We have to be told about those. And this is where you can use our API and link it to your CI tool so that you can then tell us about things like code changes or anything external to the database. And we can make these into hyperlinks as well, so you can actually click back into Jenkins or whatever CI tool you're using, and you can see more details about that particular code release there. So as I said, we're pretty close to understanding what's going on here, but just to show you, a few other things we can do. So on this top chart here, we've got the option to show the wait states. Now the wait states here, this is a Postgres database, so we think things like buffer mapping and data file read and so on. So we've got lots of that going on there. That means we've got lots of IO intensive work happening during these times. We can also click the button here to show the host metrics. What you can see here is when the database time is high, our database host is running 100% CPU utilized, and when these indexes are added here, the CPU time drops down here. And then if I scroll down to the bottom here, we've got our top statements view. We can also view top databases, top sessions, top clients, users, and programs. Quite often, the thing that you're looking for is to understand your top SQL statements. So if I go to the statements tab here, I've got 4 statements, and between them, they account for maybe 95% of all the database activity on this server. And that's not uncommon to see this kind of thing. You quite often, you get any database we analyze, you can find that there's a number of statements at the top of the list that are generally accounting for like 80% or more of all the database time. So in this case, it's these 4 statements. We can click into that top one. We can then see the profile of just this one statement now over time. And obviously this one is also one of the ones that's impacted by those index changes. And if we scroll down, we've got the full SQL text, so we know what the statement was doing. And we've also got the execution plans. In this case, the number 2 here means we actually had 2 execution plans for this period. And you can probably guess what they were, one using the index and one not using the index. So first of all, we have this plan, which is doing the index scan on the index here with a cost of 20,000. And then we've got our second plan where the index had been dropped at this point and it had to do a sequential scan of the whole table with a much higher cost here of 302,000. So that was the first example I wanted to run through. If I go back up to my instances view, I'll show you a couple of other different database types, and hopefully what you can see is that it doesn't matter if I go to, say, Postgres, This is a Postgres 5.7 database now, and the view that you get looks exactly like what we just saw for Postgres. The only difference being these wait events now relate to MySQL rather than Postgres, but other than that, you've got the same kind of look and feel. So in this case, it's a slightly different scenario. The database time spiked very high for this 5-minute period. Again, I would show the wait states to see what they were. And you can see it's actually waiting for table metadata lock is that big red bar here. And so even though that spike only lasted for 5 minutes, you've got close to 2 hours of wait time within that 5-minute window, because what you've got is lots of sessions all queued up waiting for that lock to be released. And again, you can then get all the way down into the kind of low-level details, which is the SQL statements, and see, okay, this was my top SQL statement. This spends all of its time pretty much waiting on that lock to be released. And then just below here, this is the culprit. The thing that's holding the lock in this case is this lock table statement here. So that was a simple example from MySQL. And if we was to look at any of the others, you would get exactly the same kind of views. You know, Oracle would give you the same kind of view, but with obviously Oracle wait events, things like DB file scattered read, sequential read, and so on. So what we're trying to do is go for consistency across the different products and give you the same view no matter what type of database you're looking at. Something else I wanted to show was a bit more around the kind of change detection side of things, and then how you can look at the impact of change. So we have a change history screen, and you can look at over any period of time, and you can see the number of changes there were. So for example, I could look over, let's say a 24-hour period, and it would show me all the changes and how many changes there were in each of these hours. And then below it will list those changes, and you can see it's things like the index creations and code releases, but also I think possibly, I'm not sure if you have any of this. It would also show things like database parameters and those kinds of things as well. So the next thing then, so having detected the changes, you saw how we overlaid them onto the timeline in the previous example. Taking that a step further then is you want to be able to do impact analysis of any change. And that's where we've just added in this release our time comparison feature. So if you go into the time comparison feature, you can select a database, and let's say I'll go for the Postgres 11 one that we looked at is probably a good one to look at. If I go find a period where I know there was a change. So if I go from say 2 o'clock here to let's say, I think if I go for 2:17, and then I can compare just a 10-minute window. So 10 minutes starting at 2 o'clock and 10 minutes starting at 17 minutes past 2. And then in between the two time ranges, that's when my changes happened. And I want to see what the impact of those changes were. So if I click generate to generate a report, this does all the analysis for us now to figure out what the differences were between those two time ranges. And in this case, you can see this is the benefit of adding the index. So the database time, it was close to 4 hours, and it dropped down to 2 minutes, so 99% improvement. Whilst at the same time, the throughput, the number of executions actually went up from 9,300 to 10,000. So 7% increase in throughput. Average response time for the SQL statements went from 2 seconds down to 14 milliseconds. So this is the kind of improvement you can get with things like database indexing. You can see the impact on the database host. So it was almost completely maxed out on CPU, and now that CPU has dropped down to a lower number. And then as we scroll down through this report, we go into lots of details. So this was the before, and this is the after, so the period A and the period B. We can see it by the wait states. So the wait states were obviously very high before adding the index, and now they suddenly dropped to virtually nothing. These are the top statements. And again, after making that index change, those statements barely even register now. This is the host CPU and memory. And then we even have it down to the individual statement level. So you can expand the statements and see this statement here. This is the performance profile before the change, and this is the performance profile after the change. This little icon here means that it actually switched its execution plan. So you can see this is where the changes occurred. The two changes occurred between period A and period B. And then this is when we picked up the fact that the execution plan had changed. And if I go right down to the bottom, we've actually got our changes listed here as well. So we've got changes within period A and B, and then the interim changes. So these are the two things that happened between period A and B with the two indexes created. And so you can see those two indexes obviously have a massive impact in this case on the database performance. So this is the first iteration of this report. This will be in the release that comes out next week. And then we want to take this further and be able to launch into this automatically from various points in the product. So anytime we do a change, anytime we detect a change, you can automatically get some kind of impact analysis like this to see whether it was a positive or negative change. So I think that's probably everything I wanted to show. I don't know if anybody has any questions they wanted to ask.
Yes, there are some questions. So first of all, the questions are mostly related to the performance. So is there any performance impact of what the data, so you collect so many data points and metrics. So how do you actually deal with the load on the database itself? And do you see the increased load on the database? So what is the cost of this monitoring, I would say?
So the cost of the monitoring is really low. It's hard to put an exact figure on it, but it's you're talking like 1% or something around that order. The reason being is that these days databases provide these kind of metrics in their performance schemas, and you can get these without too much cost now. So if you're looking at Oracle, you can use the $V tables. If you look at SQL Server, you can use the diagnostic management views. If you're looking at Postgres, you've got things like PG statements, stats, and all of these don't really have much overhead these days. In the past, if you go back to when we first started, like 20 years ago, some of this could be expensive to collect this data, but these days the impact is negligible.
Okay, great, thank you. Another question is related to the sizing of the server itself. So are there any estimations on how you plan the installation? So how many resources you need to store all this data? So first of all, the question is it all stored here, or you query the database often, or it's just one time and you collect the data, store it here, and then what is the size of the storage that you need to actually run this?
That's a good question. So I've just linked into our docs, so you can get to the docs. Either just go to docs.dbmarlin.com, or there's a link over here on the side menu as well. Actually, within here we have some sizing guides. So if you go to the hardware requirements, we've got some ideas for different number of database instances you want to monitor. So for example, let's say you want to monitor up to 20 database instances, then you're looking at a kind of medium profile machine with a couple of CPUs, maybe 8 gigs of RAM and 200 gigs of disk space. Disk space tends to be our main requirement just because of the granularity of data. We're collecting 1 second data. So disk space is probably your biggest requirement there.
Mm-hmm. Okay. Let me just emphasize this in Russian. То есть был вопрос по поводу масштабирования самого сервера и как все эти данные собираются, как они хранятся. Ну, то есть как бы эти данные уже отдает сама база данных. И, соответственно, там раньше это была очень дорогая операция, сейчас это недорогие операции в части производительности, накладных расходов, оверхеда. Естественно, все эти данные хранятся на сервере DBmarlin, и он сам не очень-то большой нужен. Естественно, конечно, самые большие требования к жесткому диску, ну, потому что объем данных, понятное дело, чем больше там транзакций, операций, тем больше нужен объем данных. Окей, пожалуйста, пишите еще вопросы. Мы пока ответим на остальные. Okay, there was a question regarding the pricing as well. So, for example, if you have an Oracle cluster, so is it one instance or each node is an instance? How do you price clusters? And the same question for primary and slave. So if you have primary database and slave database, how do you price those?
So if you take Oracle, first of all, so if you're using Oracle RAC, the real application clustering, then that's active-active. So you would need a license for each instance within the cluster. So if you had a 2-node or cluster, that would need 2 licenses, or a 4-node cluster would need 4 licenses. When you get to active-passive kind of setups, so like master-slave replication, it really depends whether you want to monitor both of them or not. Some customers, if they're only replicating for HA or DR, high availability or disaster recovery, they may only want to monitor the primary, in which case you just need 1 license. And then if that ever failed over, then you would just monitor the other one only at the point where it fails over. In some cases, though, you may be using master-slave replication where like all the writes go to the master and all the reads go to the slave, in which case you probably want to monitor both of them in that case. So if that was the case, then you would have a license for each of the master and each of the slaves. That makes sense.
Okay, great, thank you. So another question was, is it possible to try out the product? I think we already showed a few things how to do this. So can you walk us through the process? So how do you get the license? How do you start the trial, or is there any free usage allowed or something?
So yeah, if you go to the website and put in your email address here, it says free forever. The free forever means you can monitor 1 database instance, and that's forever. You don't need to get a license key for that. That license key is actually built into the software when you download it. Generally what we do is we then offer people a trial. So if they wanted to run it on more than 1 instance, we would let them have a license key for, let's say, 5 or 10, and let them run it for a number of weeks, so they could do a proper evaluation. So yeah, it's simple to get started. Just basically enter your email address here.
Okay, let me translate this. В продукте уже вшита лицензия при его загрузке. Лицензия распространяется на 1 инстанс. Эта лицензия бессрочная, всегда бесплатная. Если вам нужно подключить на пилот, грубо говоря, там 20 или 120 баз данных, напишите нам. Контакты есть, собственно, у каждого, кто получал email на регистрацию на это мероприятие. Там, соответственно, есть мой контакт, и вы можете мне написать, и мы вместе с DBmarlin сделаем вам триальную лицензию на нужное количество инстансов и на нужное время, чтобы вам протестировать. Ну и, соответственно, по любым вопросам также будем рады, готовы вам помочь, подключить, протестировать и, собственно, получить нужный результат. Okay. Do you plan to support Sphinx, ClickHouse, or Elasticsearch?
So we don't have any plans right now. At the moment, we're basically trying to figure out which one we do next. We've got the big 4 relational databases. There've been requests for a number, including those ones you just mentioned, but we don't have any kind of timescales for those. At the moment, the thinking is that the next one may be IBM DB2. It may be something like MongoDB. Those are the ones that we're hearing most from customers. But eventually, yeah, we want to cover as many as possible.
Okay, great. Есть ли еще вопросы, пожалуйста, пишите. So we're waiting for a few more questions. Okay, it looks like there are no more questions. So I think we can wrap it up.
The next steps here for anybody who wants to get started. So they can download a copy. We already talked about that. A couple of other things you may want to do. On LinkedIn, if anybody uses LinkedIn, we have a community page there where you can follow and get all the latest news. And we also have a Slack community. So if anybody wants to join the Slack community, you can join that, and then you can ask any questions or ask for any, if you have any problems or any feature enhancements, then we'd encourage you to get in touch with us that way.
Great. Мы призываем всех попробовать продукт, мы призываем всех скачать бесплатную копию. Если вам нужно больше лицензий, ну, для пилота, опять же, напишите нам. По поводу технической поддержки, естественно, да, мы занимаемся технической поддержкой. Мы напрямую работаем с вендором, поэтому будем рады вам помочь исследовать этот продукт. Соответственно, записи, все материалы мы пришлем по результатам этого вебинара. Большое спасибо за активность, большое спасибо за ваши вопросы. Сейчас мы закругляемся и будем рады видеть вас среди пользователей этого замечательного продукта. Thank you, Mick. It was great having you here today. I think we covered all of the questions, and we'll send over the slides and the recording. Thank you so much.
Excellent. Thank you, Dennis, and thank you everybody for joining.
Всем спасибо. Заканчиваем. Всего доброго.